Hey guys, Teresa with IRG here. I'm putting together this video for you. We did one about 2 years ago about how to calculate the frequency of your EVP sample or your audio sample, but the program I was using didn't have sound. So the one I have now actually allows audio. So I wanted to redo the video and be able to actually talk to you and explain to you what we did with Gateway and how we analyze our EVPs for their frequencies to determine whether or not they should have been heard at the time of recording. To get started, a couple things. First, I'm just getting over being sick, so periodically you'll hear me mute the mic to avoid coughing in your ear. It's not your speakers. You won't hear anything, but it's not your speakers, so don't panic. Second thing is, and I've made these same comments for the video for the tutorial for the video analysis programs. Let's keep the comments, questions, and concerns respectful when you're commenting. We don't tolerate nasty comments or disrespectful comments. Play devil's advocate and give us your constructive criticism. We have no problem with that, but as soon as you guys start getting nasty, we're going to delete the comments. This is not the place. So to get started, one of the things that you are going to need to know is what you're looking at when you're analyzing your waves. Now, I have a couple of pictures here that I can pull up for you to teach you wave anatomy. 1 second. Okay, my apologies. I'm going to start with this one because there's two different formulas that you can use for waves. You can calculate the wavelength or you can calculate the frequency. Wavelength determines the distance and frequency determines the time. So the one that you're going to want to look at is down here. It's the period, and it's F equals 1 divided by period to get your frequency. Wavelengths we're not concerned with because we don't calculate wavelengths when we're analyzing audio. It's only when we're analyzing video that we use the wavelength formula. So your period is what you need to calculate your frequency, especially if you're going to do it manually. Now I'm going to pull up this because this will teach you the actual anatomy of the wave. Now this wave is actually called a sine wave, and there are, I think, 4 types of waves. There's the square wave, actually you know what, I have it pulled up too. Sine, square, triangle, and sawtooth. These are potentially the different waves that you'll see depending on your signal. And you can Google this to learn more about them. But typically for audio samples, when you're using your analog and digital recorders, you'll get the sine wave. So let me minimize that. But all waves are going to have the same characteristics. You're going to have your trough and your crest. Your trough is down here, your crest is up here. For digital, this would be on, off, or ones and zeros. What you see here, this Y represents your amplitude. There are multiple names for this. You can call this amplitude, you can call this power, you can call this energy. This 1 and 0 is also your north and south. You can call it polarity. So there's multiple names that you can call it: power, volts, and energy, amplitude. Just a few of the examples. So you have your potential energy here for all you science buffs out there, potential energy here, your kinetic energy here, and then of course potential and kinetic again. It just repeats. North and south, on and off, ones and zeros. You get the gist. And this would be your wavelength, the point between 2 crests or 2 troughs. Okay? And of course, there's displacement, something else you can call it. Now, in order to calculate your frequency, you're going to need to look for 1 oscillation per second. Okay? Now, you can see down here, frequency is the number of oscillations per second. Now, I typically use the point from 0 point to 0 point on and your 0 point is just the line that goes through the middle. Okay. There's a more technical explanation for that. If you Google 0 point, it'll pull it up and you can learn more about it. But you can use just about any point on the wave to calculate the frequency. Any point between A, B, C, D, and E, F. Any point on the wave to the corresponding next point. I find it's just easier when calculating frequency to use the 0 point from, there's lots of things going on in the background too, guys, so just forgive all the noises. So from C to D, it would be the most efficient way, the most effective way to figure out your frequency, and I'll show you why in just a minute. Give me just a minute. Okay. Let me show you this. For those of you who know the electromagnetic spectrum, this will be pretty easy for you to understand, but for those of you who don't, your electromagnetic spectrum is organized by frequency, wavelength, and amplitude. Okay? Now, when you see a sine wave that looks like this, what you're getting is a signal that has a lower frequency but a longer wavelength. Doesn't have quite as much energy, but can travel further because it doesn't attenuate. You don't lose your signal. It can travel further. This type of signal is used, for example, on submarines and in mines, because the signal will actually travel through other materials like water and earth. For your medium frequency, you can see the difference. Your wavelength is a little shorter, your frequency is a little bit higher, and then of course for higher frequencies, let me just scroll in so you can see that a little bit. You're going to have a higher frequency with an even shorter wavelength. You're going to see situations like this, for example, gamma rays. These are really close together. You have a higher frequency, higher oscillations per second, but you're going to have a shorter wavelength, which means the point between the cross and the trough and crests are going to be closer together. These tend to travel quicker, but they attenuate a lot faster. So that's the type of signals that you're going to see. And of course any point in between. So let me see, that's pretty much a crash course in wave anatomy. So make sure that you do your research on the different types of waves, like your sine, your square, triangle, and your sawtooth, so that if you get a signal like this, you know what you're looking at. But for your audio, again, you're going to see the sine waves. So let me minimize this and show you how to calculate your frequencies. Now we use 3 programs: Audacity, Sonic Visualizer, and Praat. Praat is an open source software program that was developed by the University of Amsterdam, I believe it was Amsterdam, by 2 professors. Now, Praat is an actual audio analysis program. Audacity differs because I think most of you are familiar with it. It's an actual editing software program for DJs and things like that, musicians. Praat, the algorithm has been under scrutiny just because it tends to create what's called artifacts on your hold on just a minute. Oh wow, okay, cool. It creates artifacts which are false points, and you can Google that to learn more about it. So make sure you guys really understand your programs before you use them. Now, I'm sure you're looking at this and wondering what this is and why I didn't mention that. Let me pull that up and I can show you. Just a minute. If you'll notice, it went quiet and you didn't see anything on the screen. This is a real-time wave representation. you can't actually, there's more features that you can get, but we don't use them. For this one, you can use this during investigations to see waves coming in real time. Let me do it a little bit slower. There you go. Now you can't record this. It's very basic just to see the waves, but you can record the screen or, put a video camera on it or something to see what's going on. But this is really helpful during investigations. Now over here in the green box, you can see that it's showing you the different frequencies that are coming in and how fast they're doing. And based on me talking, you can see the volume level here. And then you see the way the waves are doing as I'm talking. Then again when I'm not. And then again when I have it muted. So very useful. And again, that's called audio visualizer. I'm getting tongue-tied over here. Now all three of these programs are free. Praat again is open source, so you can change it. If you know how to do algorithms, you can change it up. They do make that available. I'm going to get rid of this so that I can show you how to do that later. There we go. So what I'm going to do is I'm going to start with Audacity because that seems to be the one that everybody knows. Now Audacity has certain file formats that come with it. I think WAV and MP4 are two of them, but if you have a file format that is not included, or it doesn't recognize it when you first open the file, excuse me guys, if you have one in which the file format is not recognized, what you're going to need to do is go to let's go to the manual and go down to let's see if we can find it in the frequently asked questions. Go to frequently asked questions, and what you're going to want to look for is the FFmpeg library. There we go. And what I did just right there is I just hit Control F and typed in FFM to be able to find it a little bit quicker. So it's under Installation, Startup, and Plugins. You're going to need this plugin for file formats that are not already included. Okay? And this pretty much explains that. Now install, let's see if we can find where is it at? I don't think that's it. Hold on. Oh, there it is. Locating it manually. Hold on. Let me scroll back up. Here it is. How to download. Now, let me see if I can find it because it's going to be in the preferences. Import, export. Extended import. Oh, where the heck is it? It's been so long since I've done this. I've had this program for years, so libraries. Okay, that's where it is. Here we go. If you're not certain if you have it, go to Edit. Let me walk you through this. Go to Edit, go to Preferences, go to Libraries, and you can see where it says Locate. So you can see I already have it, so I don't need to download it. But if you don't have it, just click Download. It'll take you to the internet and take you to that same page that I was just on. There. See? And then you can download it based on your operating system for, other file formats that are not included. So that's just a really good option to have anyway, as I already have it included. Alright, so let's get started. Now the file that I'm going to open is a WAV. Okay, so it's already included. But let's just say it was a file that the library didn't recognize. You would want to import the audio rather than open it. Otherwise it won't open it for you. So click File, Import, and then go to Audio. Sometimes it'll ask you. Sometimes it'll ask you to import raw data too, which you can do that as well. But we'll just run it through as audio. And I know the title of it, so there it is. If this pops up, make sure you read it, because if you save this, your changes, and you lose your original file, short of doing a restore on your computer, it can be difficult and you'll lose your original audio, so be careful doing that. I usually make a copy of it. Now when you open your file, this is what's going to come up most of the time, depending on your settings. What you're looking at here is the actual waveform for this particular sample that I have. But if you click this drop down menu here, you'll see what's called the spectrogram. Now this is a highly useful tool, and I suggest that you guys do as much research as you can on the spectrogram and the spectrum as possible to learn exactly what you're looking at. Now let me just give you the Reader's Digest version. The spectrogram is a three-dimensional representation of the waves of your sample in false color. So it's kind of like looking at I equate it to looking at a thermal imaging camera. So you can see the different intensities of light based on the color. So for the spectrogram, you can see the varying intensities of the signal and the various colors as well. So the white, the Audacity manual explains this as well, so look that up. Let me bring that back up real quick. Go to the glossary and then go down to spectrum. Here we go. Presentation of a sound in terms of its component frequencies. It's basically just a 3D representation of the frequencies. Okay, now they do have an extensive article on the spectrogram so that you can read a little bit more about it. I just don't remember exactly where it's at. Is that it? Drop down menu? Yes, there it is. So go to index, go to track drop down menu, and then what you're going to do is scroll down and it will explain the different types of tracks that you can see. There's the spectrogram right there. And it will explain it. Higher frequencies are at the top of the scale, lower frequencies are at the bottom. The blue color is the least energy and the red white are the most. The progressive increase of pitch in this particular example is demonstrated by the upward sloping diagonal line. It also confirms that the word Audacity has the most energy in the middle of the word, okay, which you can see here. Now, and I'll explain why that is here in just a minute. So make sure you guys look over this manual, because the spectrogram will really help you understand what you're looking at. So you can see based on the white the points of highest energy. Now I'm going to play this for you, and what you're going to listen for. There's investigators talking. There's three sections, three AIs in this sample that we were interested in, and AI means areas of interest, what we call it before we're ready to call it paranormal or EVP. The white parts are going to be sounds and talking from investigators and EVPs that have the highest energy. The consonants are going to show the least amount of energy. The vowel sounds are going to show the most. So I'm going to play this for you, and I'm going to mute the mic.
This is a nice shot. I have to be on this sheet when this isn't going to be. Thank you.
That's north, right? Okay. That's right. That's good.
Oh, there was two sheets.
All right. pretty sure you could probably identify, this was class A, and I'm pretty sure you can probably identify the point I was talking about. There are three, and they're in between here. That's not right is the one that we're interested in. It's class A EVP. Very clear. Everybody knows exactly what it's saying. So this is the section that we're going to be analyzing, but there was one here, there was one in the middle right here. Oh, kind of a whisper. Hold on, let me go back. Right there, you can hear the whisper. And then of course this one. That was the other one. So the spectrogram will help you see the points within your sample to concentrate on. Okay? Now, for those of you who are not very familiar with Audacity, you have your different scales, and you can set these scales based on your preferences, but I just keep them at the default because we're calculating frequency and I want to see what they are. Frequency, which is time, not wavelength. So this, I keep my scale at time. Now let's start with this one here. What I'm going to do is I'm going to go back to the waveform and I'm going to show you how to do that. Now you're going to be playing and adjusting and playing and adjusting constantly. So go up here, hit your trim audio tool when you found the section that you're interested in, and you can keep zooming in and trimming it to narrow it down. And then you can also hit your space bar. Come on, cut. I'm going to eliminate that last blip because that's a knock by one of the investigators, a sound. So let's trim that. Now I'm gonna zoom in a little bit more and I'm gonna cut from here to the end. Oh, there we go. And I'm gonna zoom out and go back to the beginning. There we go. And then I'm going to play it again. Alright, the area that I'm interested in is actually going to be here. Because it is, as you can see, it's distinct from the rest of the waveform. You can see there are three words. That's not right. But these are not the points of highest amplitude. So the one I'm going to be interested in is here. After I've confirmed that that was not an investigator, that's the point that I want to analyze. So what I'm going to look for is an oscillation. Now what you're seeing here is different harmonics. Okay, you're going to see this with, this is a good example here. Let me zoom in some more. And that's actually a really good section to analyze, so I'm going to crop that. Okay, you can see the jagged edges that I was referring to, that's kind of up and down during the oscillation. Now this right here is the oscillation. That's the cycle that I'm looking at. Now what I'm going to do is drag this out just a bit more, because I've hit the space bar when I'm typing and it's messed it up and I have to go back and find it again. So I'm going to crop that. Now again, see the manual for the explanation of these. Let me see how far I can zoom in before they disappear. These tick marks. See the Audacity manual for the explanation of what that is. Zoom out some more. Alright, I'm going to show you how to manually calculate the frequency for this cycle, this particular section of this particular cycle and this particular sample. You're going to have endless number of frequencies coming in, so keep that in mind when you're doing this. Give me just a second. Alright, the first thing you're going to want to do is identify the difference between your harmonics and your cycle. So I know that it's right here and right here. Now, let me point out one other thing too. The more you zoom in, you're going to get this effect here. I don't know if you guys can see this. You'll see that the gray bar down here in the waveform actually stops, but it extends up here. Pay attention to this up here where your time is. That's what you're looking for. What I'm going to do is I'm going to adjust this a little bit closer. And there, and then, because it's off a little bit right there. So you'll see, I don't know if you guys can see that, the arrows at the end, that's what you want to pay attention to. Now this down here is what you're going to use to calculate your frequency, but this is rounded. To make your results more accurate, go up here, and I use it if I'm calculating manually doing this most of the time just because it's a little bit more accurate, but this is not always possible. Your waveforms may not always be this defined, and I will show you why in a little bit. Now you see it goes from 13.68550 and the next thing I see is 13.68560, so it's in tens. So this would be, this tick mark right here would be 68555, so it's going in fives. So from 5, we'll say that's, estimate that to 7. Alright, and then do the same thing down here. So 13.687.4, we'll say 13.68741 is what we'll average that out at. Now your formula for your period is you're going to subtract your time to get your length, which you can do down here, 0.002, and I already know what that's going to be. That's going to be 500 hertz, but I will show you how to calculate it manually. So we're going to take this time, we'll say 13.68, whoops, 687 4, we'll just do it at that tick because it's a little bit closer. So 13.68740 minus your end time, or your start time, which I calculated to be about 13.685, let's see, 5. That's going to be about, give me just a second. That's what I'm interested in right there. We'll say 7. So 68557, and then hit enter. So this right here is going to be my manually calculated period, 0.00183. Now I'm actually going to write that down so I don't forget. 183. Alright, so the period for where I have the placement is 0.00183. Now your formula for frequency is 1 divided by your period, because you're looking for oscillation per second. So 1 divided by 0.00183. So 546, and this is exactly why I said this, because this is a little bit more accurate. Now we'll round this to 546.4 hertz. Now if I was to use this number down here, this 0.002, I know that's 500 hertz. So it just makes your range a little bit more accurate. It was a little bit more time consuming, and that's why Gateway took me so long. The first phase of Gateway took me so long, because I did this with every sample I had. And I did this with every sample I had to make it more accurate. So let me, it was I'm actually going to write that down, 546.4 hertz. Now I know that on the spectrogram, the 500 range is actually the ultra low frequency range, which is the range used by submarines and mines. It ranges from 300 to 3000 hertz. So I know that this particular section was coming in the ultra low frequency range. And the range of human hearing is actually, depending on the source that you're looking at, can be anywhere from 20 to 20,000 hertz. So this is well within that range. This should have been heard, but it wasn't. And that's just one section of 3 different words for an EVP. Now, let me do Control Z. And scroll out. Now, you can do this along this entire section manually if you wanted to, but there is a much easier way to see the range of frequencies for this section, because I know it was this word, and this word. I would be interested in knowing the frequencies for this, and for this, because they're the points of highest energy within the words. So I would want to know what the frequency ranges were for this, and this. To do that, I would go to Praat and a sonic visualizer. Now I'm going to show you Praat first, because Praat has a lot of really good, you know what, I'm going to take this off because I already trust this publisher and just run it. Now when you first open Praat, you're going to have 2 windows that pop up. The Praat picture I don't use. You play around with it and do what you want to with it, but we don't need it, so I don't use it. I usually just close it out. But your Praat objects window you will need. So when you open this, you're going to go to Open, Read from File, and then pull up your, and it doesn't already have it open, so let me go to it. Give me just a minute. Whoops. There it is. And then open it. Now, I'm going to show you the steps that we do, because I used this in the second trials of the first phase of Gateway for the study, just to verify my findings from the first trial. From the first trial, I only used Audacity. I didn't use anything else. But in the second trial, I used Praat. So I'm going to show you. My object is just my sound file. So I'm going to pull that up. Now, come on, it's frozen. Oh, come on. Thank you. When you first open your sound file, this is the window that you're going to see. You can listen to your wave in 3 ways. You can listen to a section, by selecting it. I think it's over here. Maybe it's right here. Yep. So I would select a section, left click, and then drag, and then hit this. Or I can listen to the entire visible part. Or I can listen to the total duration. Now let me make this bigger, and you'll see that when you highlight a section, you have your start time, you have your end time, and then it's automatically going to show you your period. So there's really no need to manually calculate. I am going to use this to zoom in a little bit. You can zoom in, you can zoom out, you can zoom into the selection, you can hit back. Now, oops, that's too far. One of the criteria for us to qualify something as an EVP is the recording has to be absent any other sounds or voices. So, for example, hold on, let me go out. Find a good section. Alright. I don't know if you guys can hear that. Let me see if the volume's turned up. You can hear a whispered EVP that comes in right there. But the problem with using this section of the recording is this thud that goes on in the background. That's going to throw my results off, so I would not use this section of the recording as part of the analysis. The recording has to be absent investigators talking. It can't be above or below. It can't be louder than the investigator. It can't be lighter than the investigator, even though you can hear it. That's one of the criteria, and it just helps us to eliminate problems with the analysis. Now I hear something in the background here, so I'm going to further isolate it with just that. I know that that's part of this area of interest. So that would be the only section of the recording for this particular EVP that I would actually include. And let me go back to it. There we go. That I would include in the experiment. Now you can see this line here. This is your 0 point line, represented by the 0 here. Let me see how far I can zoom in before it will isolate it. Now, again, you can see the oscillations here. The ups and downs between the north and the south, the ones and zeros, etc. These are your different frequencies, your different harmonics. So let's see how far we can zoom in before it will eliminate it. That's pretty good. So what I'm going to want to do is find, we'll say from this point up and down to here. This is one complete oscillation because it crosses the 0 point line. Now, I'm sure that when you saw the file originally open up, the spectrum and the formants, and I'll get into all that in just a few minutes, but what I want to do is go back to my window, my objects window. Now, for serious researchers out there, this is a really good option for you in this program. We like to take notes when we're making our observations, so we will annotate the file. Let me see if it'll pull. Is this it? Hold on. Because usually it will. Well, it's not going to let me do that. Okay, that's the spectrogram. Let's just get rid of it. I wanted to see if it would let me do it, but it won't. Alright, we like to annotate. And what you're going to do is you're going to text grid. You're going to go to annotate text grid. Where it says Mary John Bell, you can type in whatever you want. It will only do 3 at a time, and you have to have your spaces, and they will be separated. So we will do the file because we name the file, and then we also have an information section. And then you just get rid of this and click OK, and it will open up another object. Now to open them up together, you can open them up by themselves, but to open them up together, you have to select them both at the same time. You can hit Control and do it that way, and then hit View and Edit, and this is what will come up. Now you will notice this bar here. Whoops. This will allow you to section out the recording. So let me play it. Okay. Now I know that the section that I want to look at is between here, so I will hit this button and here, because that's the thud sound. And you'll see how it turns red. And then you can move it, but it's pretty much already where I want it. Click in the middle and then play again. And I can also move it over, and then I will further isolate this by zooming in. Alright, now let me zoom in a bit. Nah, that's too far. That's why I don't like doing that. Now, up here, you'll see where it says File and Information, and that's what I typed in to the object window. Let me move this over a little bit. We'll start it right about there. And usually what I'll do is, if the words are not running together when the EVP is, and I'm going to say talking, is I will isolate these into individual files for each word. If the words are kind of running together, or they sound like they're kind of running together, I'll just do it as a range, but I will create individual files for each one. So I can click on this, I can click on this, and then this. Oh, there's one more. And then I'll bring this over here. Actually, it's a little bit further because it's the word right. It's going to be drawn out a little bit. That's not. Hold on. Let me remove this boundary. And this one too. That's the A and the S. That's not, and then right is actually down here. So I would type it in, and you can type it in by clicking here, or you can click up here. I'm sorry, you got to click on this to type it in, but once you click on it, you can type and it'll automatically input it, or you can type it up here. Very simple. Now usually we'll do this actually down here, but the file name would be up here, but you get the idea, because you can do this with both the top and the bottom. So let's say, oops, wait a minute. Hold on. It's been a pain. I can't seem to type today. Let me go over here. My Control A is not working. Okay. And that's just for general. Let me make this bigger. Okay, there we go. Now, once you put in your boundaries, click this, click it again, and then click this, and you're going to do the same thing down here to create your boundaries. And then click on the bottom section again. That's not right. So I have both my file name and the word that it's saying, and of course you can type in other observations like highest. I noticed that the highest point of energy was on the vowel sounds for the A and the S. For the I'm getting distracted, I'm sorry. Got some things going on. And for the A and the S were the points of highest energy. So you can hear that. And then the same thing for the not. The O and the T are the points of highest energy there. And actually I could probably move this back just a hair. back a little bit further. And actually it would probably extend out further, but usually I just go to where I can actually hear the vowel sounds. So that would be right there, and then the T's here. And then for the right, the IGH is the point where it's highly enunciated with the most energy. So the I would be right there. And these would be the sections for this particular sample that I would analyze for the EVPs. Now if I click on each one, I could see the period for the entire thing. I don't want to do that because it's going to make my results a lot less accurate. So what I would do is go to each one after I've set my boundaries. And it would be, wait a minute, too far. Click on my selection, and I'm going to want to look at probably that. There. Now, you can see the harmonics there and the different frequencies there. But this, oops, and you can actually zoom in. I'm just going to mark it so that you can see that, is one oscillation. Now that I have my boundary, I can zoom in some more. And the further in you zoom, the more you can see it, and you can refine it to make it more accurate. As you can see, it's not quite right, so let's move that over, because I want it at the point where it crosses the 0 line. Okay, so there. And then just go over here. Wow, that was actually pretty spot on. Now I'm going to zoom out just a little bit. So that's one complete oscillation within that section. And you can see my period's already calculated up here, 0.001085. So let's plug that into our formula. And if you can do this in your head, great. I'm too tired to. 805. So my frequency for that is, come on, oh wait a minute, 1 divided by 0.001805. There we go. So I know that my results are accurate because you can see it's still within the 500, 550-ish range. So I can see that my result from the last time, even though this is not the same section, is it's staying consistent. Because remember, we're just looking for a range, you know, because you have frequencies of lots of different ranges, so you're just looking for a general range. Now to isolate the signal by itself, you need an oscilloscope or some other piece of high-tech equipment to really get accurate results. But we, you know, for us broke people out there, we pretty much have to make do with simple stuff. So this is just a really good method for doing that if you don't have an oscope or something like that. So I know that it's remaining accurate in the second trial. Now what I would do is try to find the same time that I used in Audacity, but you know, I'm not doing that here. So I know that it's still within the same range of the spectrum. I know that's in the ULF. I know that's still in the communications with submarines and mines, and they can travel around the world. They're not confined to a specific point, because they need to be able to travel. So it's quite possible you're picking up submarine communications. I guess an argument could be made for that, but I doubt it, because the signal doesn't match. But you know, that would be a discussion for another tutorial. Give me just a second. Okay. Now, one of the things that I'm sure you guys noticed when I originally pulled up this file was the spectrogram. So what I'm going to do is, if it's not already selected, just go up here to spectrum and then show spectrogram, and it will display it in the middle, and you can still see it. So you can see that my isolation with actually without the spectrum was pretty accurate. I was able to isolate it pretty accurately. So you see the highest energy there, and there, my points of highest energy was actually pretty accurate. So what I'm going to do is I'm going to show you the, and of course let's do the spectrogram settings that you have. Okay, you can adjust your range, your window, and your dynamic, but I don't play with all that. Don't really need to. The dynamic I might play around with, but it's kind of complicated to explain. Pull up a YouTube that explains it, a YouTube video that explains it more. I don't really want to get into it right now. What I'm going to do is I'm going to show you the formants. The formants are really useful for identifying concentrations of energy within your sample. So let me just zoom out a bit. And what you're going to see when I click this setting is a concentration of formants here. So go up to formant, show formants, and you're going to see the concentrations there. You can see them there. Now again, to pull up more information for a more technical introduction to them, I would suggest pulling up YouTube and looking this up, because there's a guy that I actually contacted that explained these to me when I first started learning this program. Very, 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 very good man. So look that up. But the formants will help you. Now, let me show you something else too. The formants, like I said, just show you the points of highest concentration. So what I'm going to do is I'm going to click on, let's just get a small listing. I'll tell you what, let's go to, oh crap, hold on. And my son is going to be coming home any minute now from school, so you're probably going to hear me mute the mic when he comes in. I think his bus is here actually. So I'm going to zoom in to, let's see if it'll work, this section. Nope, that's the mailbox. Nope, that's not going to be enough. So let's do this one. Yeah. Now you'll see them in layers. 1, 2, 3, and 4. Now these are, again, look up the tutorial. They can be a bit difficult to explain. And so what I'm going to do is I'm going to do this one down here just because it's easier. So go up to Formant, go to Formant Listing. Oh, hold on. Go to Formant Listing. And what this is going to do is it's going to pull up a text file that you can save that shows you the frequencies for the formants at that particular section. Now we use this a lot for the second phase of Gateway, because this just made it a little bit easier to calculate the range, and I'll show you kind of what we did. I'm not going to go into too many details, but the info file that you saw me delete earlier, that's what this is. So what I'm going to do is show you the format setting. I only have 10 dot size. You can make it bigger, and you can also change the format in hertz, but I don't need to because most EVPs don't exceed the 5,000 range, so I don't really worry about that because I'm just worried about the points of highest energy, which tend to be down in this area. So I'm going to pull that back up and show you as soon as I find out where it's at. There it is. What you're going to do is go to File, Save As, and I'm going to save this to my desktop just as it is. You'll see it saves it as a text file. Hit Save, minimize it, open up Excel, go to Data, From Text, pull it from your desktop. And what this is going to do, make sure it's, import at row 1, and that's right. And good, they're already divided, so they're not going to, so I can manipulate individual cells if I wanted to. General, and text, date, yep, that's right, because I want to keep the formatting as it is here. Hit finish. Make sure you select where you want it to start and hit OK. And then it's automatically going to put it in. I already know which one's which, so I'm just going to delete that top row. I know this is my time, format 1, 2, 3, and 4. So you can import your frequency information into a Excel spreadsheet and create graphs and bars and all sorts of different things for those of you who know how to use Excel. If you don't know how to use Excel, learn. Pull up tutorials and learn, because this will be invaluable for those who want to be serious researchers. Now let me show you what we did for Gateway. What I'm interested in is the lowest frequency and the highest frequency. So I'm going to highlight this. I'm going to go to sort and filter, smallest to largest. I do not want to expand the selection because it will screw it up. So just continue with current. And then I'm going to do the same thing with this down here. And what that's going to do is it's going to show me the highest and lowest frequency for those formats, which is 469, we'll say 470, and 2440, we'll round that up to 7. So 470 hertz to 2447 hertz, 2440, I'm sorry, I'm getting tongue-tied, 2447 hertz. So I know that that's the range, the highest and lowest range, based on the formats that I have listed here. And again, just looking for a general range. You can get more detailed with this if you wanted to. Very, very useful for those of you who are serious about researching. Now what I can do is also average out the frequencies. So let me auto sum these. Oops. What I'm doing is selecting and bringing it down to automatically add these together. And then I can find out the average per format, which I would just take this number and divide by 9. Same with this and this. Or I can add them together and then type in my formula. Let's see if this will work. Equals F11, or you can just select it, and then you're going to divide by the number you have, and there's actually 1, 2, 3, 4, 5, so we're going to divide that by 5. So that right there is going to be my average, but you can see that it doesn't really work because it's a little high. So I don't really do it that way. But very, very useful for you serious researchers and science and math buffs out there, because this will help you considerably. Now, actually, it would be no, I did that wrong. Hold on. I got my math messed up. So equals F11 divided by, let's see, there's 1, 2, 3, 4. Well, I'm going to have to do the math on that. I can't do it in my head right now. 9 times, there's 4 columns, so 36. So F11 divided by 36. There it is. That's correct. That's my average frequency for these formats right here. So it's in the 1400 range. So I would classify that as the ultra low frequency, still consistent with what we had before. So you can see how this will help you further validate your frequencies when you're using Audacity. Very useful, and I suggest you guys learn how to use this. Now, if I wanted to, I could take this and turn this into I gotta figure out how to do this. If I'm showing you maybe I could use a scatter graph. Nope, not really accurate. So let me delete this. I can turn this into a chart. Well, I would have to further organize these to turn them into a chart. For this one, anyway, you get the gist. You would need to further organize in order to turn it into an accurate chart, but you can turn it into a chart. Okay, that's okay. So you can see that it's organizing the frequencies. But make sure you understand Excel before you try to do this, otherwise you're going to get, for lack of a better way to put it, laughed off stage. So make sure you understand what you're doing before you start creating the charts. I don't usually need to too much with this, but it will help. I usually just, when I get done with doing all of my frequencies and I have this number here, I will create a chart based on that, but typically not these. So this will help you calculate your average. Okay, so I've showed you guys how to use Praat. And of course you have other options here. You can do it by intensity. You can see the information over here for different aspects of it. For those of you who want to look at that information, I don't usually need it, but and that's pretty much it. You'll just have to play around with it. It's pretty much all we really need to use for the current aspect of the Gateway project. Hold on. Okay. What I'm going to do next is I'm just going to exit out of this. I'm going to close this, and I'm going to close this and show you Sonic Visualizer, because this will help you as well. So go to File and Open, or you can just hit this to open your file. Let's go back to our Class A. Now I know that the section that we want to look at, so click on this, is here, I believe. Yep. Alright. So I'm going to use my mouse wheel to scroll in just a bit. Whoops. To scroll in just a bit at this section here. To grab it, just click this. That way you don't lose your place. Now, this one will help you layer, kind of like what you did with Audacity. But what I'm going to do first, I'm going to show you pane. I'm going to add a spectrogram pane to this so that you can see the spectrum. Now down here I have my layers. The 1, 2, and 3 automatic, but you can change your layers. Now I typically put it in the fruit salad color because it really shows you the differences in the color. I'm sorry, the frequency colors. Again, your 3D representation of your frequencies. So you have your background noise, your orangish colors, your yellow colors, higher energies. Your reds and your whites are going to be the highest energy. So you can see that's not right. Oh, shoot. Give me a minute. Go back to it. It's not wanting to play it at that point here. It's being a pain. Anyway, let me show you a couple of things that you can do. Make sure you change your color around. Use different colors to get a view of your different intensities. But again, I like the fruit salad. I will also change it to the meter. That really helps a lot too. So you can see it even more. So there, 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 and there. And then of course this would be the point where the knock came from. So let's highlight this section here. Well, no, let's go further back because we didn't do the whole thing before. So you can see your different colors. You can see from this one when it shows you the decibel, the energy, and then your phase, but it's a jumbled mess. And unless you understand phase, I wouldn't worry about this part. Let's go back to meter. I'm going to, let's see, it's going to start right about there. And this is an extension of the consonant, so I'm just going to isolate to about right there. Now, you can see, if you'll look at the bottom box on the right, a box pop up that says, I know that was redundant, time, frequency, pitch, decibel, and phase. This will give you all of your information if you don't want to try to calculate manually and you just want to do like a quick review of the frequencies. If you're going to write them down and track them, I suggest using Praat and doing the format listing and go through that process. It's a lot easier. But if you want to just say, okay, well, was that loud enough that it should have, or was the frequency high enough that it should have been heard at the time, you can pull this up and look at it that way. Because this is an actual analysis program. So very useful for you. Make sure you use it. You can see the frequency, and the higher up you go, the higher the frequency is going to be. So I can tell just from looking at it that the frequencies of this particular section of the word should have been heard at the time. Because I know the further up I go on this box, the higher the frequency is going to be. So I know it should have been heard. But I can put my cursor anywhere on this waveform to see the frequency. So let's see if it'll play it. Ugh, it wants to be a pain in my rear end. Whoops. Let me move it. Let's see if I can't get it to play. There it goes. Now it's doing it. It's a little tricky to get it to work, and it still want to be a pain. But anyway, I could tell just from looking at this. I don't even have to listen to it to determine whether or not it's an EVP. I will, ask my investigators, did you hear it at the time, or was this heard at the time? If they happen to say in the recording, what was that, or did you hear that, I'll exclude it. I'll exclude the entire sample. I will not include that in the study because it raises too many questions. If it's heard at the time, it doesn't qualify as an EVP. So we won't include that. But I can tell just from looking at this that there's, some significantly high energy here, here, etc. I wouldn't know that this was an EVP just looking at it, but I can tell that it had a lot of energy. I can distinguish the fact that, okay, well, there's people walking and talking and there's lots of activity going on. Now, if this had been a recording in a location where nobody was present and you was just leaving it and all of a sudden I saw something like this here, or these differences in color, and it changed from this, obviously that would be a point to listen to. So make sure you pay attention to your spectrograms, and using that in conjunction with the waveform will really help you. And then of course you have your other options that you can change, which I don't play with these too much, but you can change them. I just don't usually need to. I don't usually use the log, so it doesn't matter. And log is a trig function, so if you're not familiar with trigonometry and math, don't worry about that. Hold on. And you can isolate it by the bends. You can isolate it by it's frozen. Give it a minute. There we go. Let me go back to this because it's gonna slow up my computer. I need to clean it up. There we go. So you can use this to see the frequencies as well. So I further isolated the frequencies just by changing a few of the selections. See, if you have it on linear, you wouldn't be able to see it. So I go to fruit salad, linear, select meter, and I can actually see it. And then of course you can change it to other things as well, but then it becomes a little bit more difficult to see. Now your phase is just a jumbled mess that most people don't understand. So again, play around with it. You can see, let's play it. So you can see that because there was more energy involved with these, that they're a little bit easier to point out, a little bit easier to see than say this down here, because this didn't have quite as much energy as the shuffling and sounds that were made by the investigators. So make sure you guys look at this and compare it. Now there's other things that you can open, different paints that you can open. Play around with it. Make sure you understand them. I'm not going to go into too much. Oh, there's a good example right there of what I was talking about earlier. You can see the actual spectrogram. So you can pick out specific points on the spectrogram, and I did that by going to add spectrum. So you can see that. Let me make it a bit bigger. And then I just panned across. Let me go to here. Hold on. And use your, if you can see this line, use this as your reference. And we'll just put it right. Come on. Hold on. Where'd it go? I'm getting messed up here. Give me just a minute. Here we go. I'm getting it. Sorry, my mouse is starting to stick a little bit. So we'll just leave it right there for now. But you can see the spectrogram, the signal that was coming in. If you use this pane here. Let me see if I can add this one to it. There we go. This is the peak frequency spectrogram pane. Pretty self-explanatory. And again, you can change the color. Very useful for looking at 3D representations of your spectrogram. Now if I wanted to add a layer, let's do this. I could do it with this one. Now I don't want to add a layer. I don't usually like layering, but you can. And then just switch this up here to layer your frequency on top of your spectrogram. I'll tell you what, let me change the color to white so that you can see it. And then I will change the, let's do that's a little bright. Let's do something a little bit darker. Note that you can't really see. There we go. So you can layer your waveform on top of your spectrogram. You can layer it on top of the range, the peak. You can add your time rulers. You can look at each layer by themselves. You can add text. Oh, I'll tell you what, let's do and it won't let me move it. Let's do it. No. And of course I would usually make that bigger, but let's see if I can. Hold on. Let me try that again. It's not going to let me make it bigger, but it's alright. But you can still see it. So you can add text. You can layer an image on top of it. Let me remove the layer and go back. There we go. You can do transformations. Now, these are for your more advanced users. So if you don't know how to use these, if you don't know how to apply them or use them or even know what they are, then just don't even worry about it because you technically won't even need it. But you're more than welcome to learn more about it. Now, if you go to your playback, hold on. Actually, let me get rid of that. I'm going to go back to my fruit salad. I'm going to scroll out just a bit. So what I'm going to do is, alright, highlighting my portion, and I'm going to loop the playback. And it's still not working. It is being an absolute pain today, because normally I can get it to play in that section and loop it without an issue, so I don't know what I'm doing wrong. There it is. That's what it was. I knew I was forgetting something. So make sure, excuse me, I got a yawn. So make sure you guys play around with this. This will really help you. If you're not concerned with knowing what the frequency was, which I don't know why you wouldn't, because it would help you isolate whether or not it was like a radio broadcast, for example. It'll help you eliminate the possibility. If you're not worried about the frequency, then don't even worry about this program. But if you're serious about learning more about your EVPs and finding out whether or not there's something to them, I would highly recommend that you invest in the sonic visualizer in combination with Audacity and getting to know Praat. Excuse me, I gotta take me some headache medicine. Personally, my belief is that for those of you that are not actually doing it that way, while I realize it's personal preference, it's actually harming advancement in the field. My group is in the encampment that we want to push the paranormal into a more scientifically evolved field, evolved and recognized by the scientific community. And to do that, we need to change things. So if you are also part of that group, then, you know, I would highly recommend that you get these programs for your analysis. I'm going to play that one more time for you. Probably one of the best Class A EVPs I've ever seen. I do want to show you this tool before I end it. This is your measurement tool. Okay, now what you can do when you've made your selection, alright, take your tool, and I don't know if you guys can see that it's cornered, so you're going to want to, let me see if I can find a spot on it. Right now it's pointing at this section right here. That's where you want to put your mouse. So I'm going to go down here at the very bottom, as close to the bottom as I can get, click, drag over to the end, and then up again to the cutoff that was for the device. There we go. And then I'm going to click this. Oh, come on. It's being a pain again. There it is. I clicked out of the measurement tool. I'm getting tired. And you're going to hear my son here in just a minute. But that's how you look at the measurement tool. So you can see, again, it'll just highlight this section, kind of like spotlighting. And you can find your frequencies. Give me just a second, guys. I'm going to mute it. Okay, so that's pretty much all there is to those programs. If you guys have any questions at all, please let us know. You can comment on the program and our methodologies and things in the comments section. If I don't get back to you right away, I'm not ignoring you. I don't always sign into our YouTube account. I don't always get the notifications because we got a million other things going on in the process. So if you guys have any questions, comments, or concerns, make sure that you let us know and we'll do our best to get back to you. Make sure you check out our Facebook page and our website. We have lots of information there too. Hope you guys enjoyed it.